Hi everyone, this is going to be a review of chapter 1 in order to get you ready for your test this week. Because it's a review, I will go through each section, give you a few pointers, present a problem, and then you will work the problem, submit your answer, and then after you submit that answer, I'll walk you through how to work those problems. So that you can check and see, make sure that you're getting the right answer and that you know how to work these problems, okay? All right, so first section here, 1.1, points, lines, and planes. So over here, we have point, line, and plane. So a point, remember, that's just a location. It's a dot. We always have to label it with a letter. A line, one dimension. Remember, it goes forever in both directions, so we have to include arrows on the end. Okay, and then we have a plane, which is 2 dimensions, okay, because it extends both horizontally and vertically. And then we have different dots on it, so different points. You can have lines on it. You can have segments, so you can have anything on a plane, okay? So you'll see here, it says it's called plane M or plane ABC. So if you label it by its points, you have to name every point on the plane. Or if we have a letter here, like M is, we can call it just by that point, okay? On the other side, we have segment, end point, and ray. So a segment is just a piece of a line, okay? It's gonna have 2 endpoints, which means it has a starting point and it has a stopping point, okay? Whenever you label that, it's just gonna be, just notice this straight line on top, but there's no arrows. Whenever we label a line, we have to include arrows on each end, okay? And then next we have a ray. It's gonna be a starting point on one end, and then it's gonna go forever in the other direction, okay? And there's a little note here. So this ray, we would call ray A, B. Okay. And then our starting point there is gonna have that end point, and then we're gonna go through as a line. Okay. And then our other one here, notice the A and the B look like they're in the same place, but when you actually pay attention, the end point is over on the B. Okay, so we have our end point and then a line that continues. Okay, so it's important to pay attention on rays, which one is the end point. All right. So first, for 1.1, we have a plane. Okay, you'll notice we have 2 lines going through it. So 1 and then 2. So your questions, what is another name for this plane? So for plane QRST. Next, we want to name 3 points that are collinear. And then last, just how many points are on the plane. All right, so looking at this problem, another name for the plane. So first we named it with all of its points. So we named it QRST. Another name, we can just call that plane V, okay? 3 points that are collinear. So co, right, means the same. So collinear means they're on the same line. So if I look at this line, I just have W and Q, okay? I need 3 points that are collinear though, so WQ, that line doesn't work. But if I look at my other line, we have R, Q, and S. So 3 points that are collinear would be R, Q, and S. Okay, and then how many points are on the plane? So this is my plane. Okay, so we're looking at the points only inside of it. So I'll see you have 1, 2, 3, 4. Okay, so 4 points. W does not count because it is not technically on this plane. All right, next we have section 1.2, segment addition. So segment addition basically just says if you take the pieces of something, it's gonna equal the whole, okay? So for example, this first one, you want to find MP, okay? So looking at this, I know that MN is equal to 5, NP is equal to 18. So if I want the whole entire thing, then I'm just gonna do 5 plus 18 to get the whole, which is gonna give me 23. Okay. This next problem, we wanna find DE. So you'll notice here, it gives you DF and EF. So you're finding DE. Okay, to find DE, I know that it's gonna be this piece, okay, which I don't know right now, so I'm just gonna label it as X. Okay, we don't know that. So it's gonna be DE plus EF, and I know that whole entire thing is equal to 63. Okay. To solve for X, right, we want X by itself. I'm gonna subtract 50 from both sides. And we find out that X is equal to 13. Okay, so in this case, this X is 13. So 13 plus the 50 gives you the whole length of 63. Okay. One more segment addition here. Okay, it just looks a little different, but we want to find JM. Okay, so you'll notice we have point J here, point M here. So I want that whole entire length. Okay, 2 ways to do it. So first way is you can look at the picture. Okay, just looking at the picture, from J to M, right, we can count. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's going to be 12 units. Or what you can do is we can take this biggest point. Okay, so we can do 6 minus, right, when we want to know how far apart something is, we subtract. So 6 minus -6. 2 negatives make a positive. So that's going to be 6 plus 6, which is also 12 units. Okay, so same answer, 2 different ways to get it. If you did accidentally do, if you did -6 minus 6, that's going to give you -12. So that's just where you have to think through it and know that distance cannot be negative, right? These cannot be -12 units apart, okay? So you just have to think when you see -12, it's actually going to be a +12, okay? All right, next going into midpoint and distance. So midpoint is a point that divides the segment into 2 congruent segments. So remember, congruent means they're of the same length. This is our midpoint formula. Okay. And then I included, there's a picture here. So you'll see we have A and B, and then we have this midpoint, okay? These lines, these two, tells you that this piece, so this AM, is equal to this piece. Okay, these tell you that they're the same exact length. All right, and then distance, that's going to be the length of the segment in between the 2 points. So you're trying to figure out, kind of like this one up here, you're trying to figure out how far apart 2 points are, right? But they're not always on a straight line, so we can't always count them like this. Okay. All right, so first problem, okay, we're going to find the coordinates of the midpoint, okay, of a segment with the endpoints, -3, 3, and then -8, 6. Okay, so you can do it using the formula, or you can do it graphically, whichever you choose. Okay, if you're going to do the formula, first thing I like to do is label. Well, this is x1, y1. This is x2, y2. Okay, so that when I go and plug it in the formula, x1 plus x2 is going to be -3 and -8 over 2. And then y1, y2 is going to be 3 plus 6 divided by 2. -3 plus -8 is going to give me -11 over 2. 3 and 6 gives me 9 over 2. Okay, and then we're going to get decimals for those. So -11 divided by 2 is going to give me -5.5. 9 divided by 2 is going to give me 4.5. Okay, so that's working it algebraically, so with the formula. If you choose to work it graphically, first thing we're going to do is we're going to plot those points. So -3, 3, and then -8, 6. Okay. The thing with doing it like this is you want it to be accurate, so we need to make sure that our lines are nice and straight. Okay. All right, and then from here, I'm going to make a right triangle. Okay, and then I'm going to count. So from this point down to even with this point, okay, that's 1, 2, 3 units. Half of 3, right, because I want the midpoint, I want the middle, so half of that is going to give me 1.5. So I'm going to go down 1.5. Okay, so I know my midpoint is going to be on that little dotted line somewhere. Okay, same thing going here. I have to count my total number of units. So 1, 2, 3, 4, 5. And then I need half of that, so 2.5. So 1, 2.5. Okay. And then you can see those cross right there in the middle, which is at -5.5, 4.5. All right, next problem is we're going to find the distance. Okay. So find the length of the segment with these endpoints. So -4, 0 and 4, 8. Okay. If you choose to use the formula, okay, distance equals square root. Okay, and then I need to label those. So we'll let this be x1, y1, x2, y2. Okay, so notice this one, we're doing x2 minus x1. So that's going to be 4 minus -4 squared, okay, plus my y2 minus y1, so that's going to be 8 minus 0 squared. Okay, so square root 4 minus a -4. Okay, 2 negatives make a positive. So 4 plus 4 gives me 8 squared plus 8 minus 0 squared. So that's going to be another 8 squared. Okay, so that's the square root of 8 squared is 64 plus another 64, which is going to be the square root of 128. Okay, and then decimal form of square root of 128 is going to give me approximately 11.3 units. Okay. If you choose to graph it, okay, we're going to plot the 2 points first. Okay, so I use that same color. So -4, 0, and then 4, 8. Okay. And then I need a straight line. Okay. Next thing I would do is make a right triangle. Okay. And then from here, you would be looking at doing the Pythagorean theorem. Okay. So we would have to do a squared plus b squared equals c squared. Okay. And then to count our units, so we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 squared plus, I know this went from 0 to 8. Okay. 8 squared is 64 plus 8 squared, again, gives me 128. Okay. And then to undo this square root here, we're going to take the square root of both sides. So again, same thing, you get the square root of 128, not squared anymore, which we know is also approximately 11.3 units. Okay. Next set of problems here, we're looking at 1.7, so the most recent thing we've done, perimeter, circumference, and area. And then remember, we have these formulas for square, rectangle, triangle, and circle. Okay, so getting right into it here. So we want to find the perimeter and the area of a triangle with a base of 24 millimeters and a height of 9. All right, so we'll start with finding our perimeter. So perimeter just means you're adding all your sides together. Okay, so I know I have 15 and 24. Okay, and then because I have these markings, I know both sides, both of these are going to be 15 millimeters. Okay, so I'm going to add another 15 here. Okay. And then adding all of that together, I'm going to get 54 millimeters. Okay. So that's my perimeter. To find the area of a triangle, okay, remember, so you can either do this 1/2 base times height, or it's the same thing as base times height divided by 2. I prefer to do base times height divided by 2, but it's up to you which one you use. Okay, so base, we're looking for where that right triangle meets. Okay, so my base is going to be 24. My height is going to be 9. Okay, so 24 times 9 gives me 216. 216 divided by 2 is going to give me 108. Units is going to be millimeters squared. Okay, so there's our perimeter and our area. Okay, last two here. So we want to find the perimeter and area of a square with sides 15 inches. Okay, and notice they all have this marking. Okay, so to find the perimeter of a square is gonna, oops, way ahead of myself here. So perimeter is equal 4 times S. Okay, so that means we're gonna do 4 times my side length, which is 15. Okay, perimeter, you just add up all the sides, but since they're all the same, instead of adding 15 4 times, I can just do 15 times 4, and I find out that perimeter is 60 inches. Okay, next, to find the area of our square, that's going to be our side squared. Okay, so in this case, our side length is 15. So we're going to do 15 squared, which is 15 times 15, which gives us 225 inches squared. All right, very last problem here. Circumference and area of a circle with a radius of 4. Okay, so before you can even work this problem, you have to ask yourself, radius of 4. So does that 4 go halfway across the circle or all the way across the circle? Okay, radius of 4. Radius is only halfway, so from the center, I know this is an oddly shaped quarter here. Halfway across is 4 inches. Okay, so that means if I go all the way across, that's going to be another 4 inches, which means the whole entire thing is going to be 8 inches in diameter. Okay, so to find the circumference, again, circumference, you can either do pi times diameter, or you can do 2 pi r, okay? I'm going to choose to do pi d just because it's less numbers, and that's the only reason why. Okay, so pi times my diameter, that's pi times 8. Okay, so that's 8 pi. And then if you put that in your calculator, 8 times pi and round it, that's going to give you 25.1. And then that's going to be inches. Okay. Next we have area. Okay. Area is equal to pi r squared. So that's pi times, remember only the radius is being squared. Our radius is 4. So pi times 4 squared, which is pi times 4 squared is 16. Which leaves us with 16 pi. And then if we do 16 times pi in our calculator, that's going to give us 50.3. And then it's area, so that's going to be inches squared. Okay. All right, so that's your review for chapter 1. Hopefully this got you prepared for your test. If you still have any questions, just make sure to send an email, and then we can clear up any confusion.